In this lesson, we're going to review and summarize some of the principles that are most commonly attributable to successful testing endeavors. There are 11 key practices we're going to go take a look at. Principle 1, the objective of testing is to identify defects and not prove that the solution works. The successful tester always works on the assumption that the requirements are incomplete, that they're misunderstood, that they're inaccurate, they are not quite right, and therefore that the solution is by definition flawed until those requirements are uncovered. So showing through testing that you've built the correct solution is of course impossible because it presumes that you have correct requirements, which unfortunately is not really possible. Of course, the fact that requirements change, that requirements are perishable, exacerbates this issue. Principle 2 states that the goal of testing should be to locate as many defects as possible in some allotted amount of time. I mean, at the end of the day, you have a limited time, budget, and other resource constraints that you're subject to, and therefore it's not feasible, it's not practical to discover all the defects. Essentially becomes a risk reducing effort to find as many defects as you can in whatever amount of time you've allotted to it. Of course, naturally, if you have more time allotted to testing, you're going to find more defects. But at some point in time, you get diminishing return. Now that implies that the solution team, the development team, the project sponsor, product owner, project manager, and so on, all have to agree on an acceptable level of quality and an acceptable number of latent defects. Principle 3, fully define the expected outcome of each test case by creating a test case definition. Don't just simply start banging away at the application hoping it's going to break, but rather define test suites, define specific test scenarios, and record them so they can be re-executed during regression testing. It also then, of course, forms the basis for being able to automate the test process. Principle 4, testers and test designers should be as removed from the solution implementation team as possible. So the idea is that an external party, somebody who's not part of the development team and the team building the solution, is likely going to define unusual and unorthodox test cases, perhaps based on their interpretation of the requirements or their interpretation of how something is supposed to work. And therefore, those test cases exercise more of the boundary conditions and likely make fewer implicit assumptions. Now, while of course developers and programmers and software engineers and so on should create and do their own unit testing, they should not perform their own acceptance testing. That should be done independently. Now, of course, it doesn't imply that you have to have a separate testing team. It just simply means that someone other than yourself on a team should be doing the acceptance testing. But naturally, having somebody outside the development team do the testing is often even better because to make, as we said, fewer implicit assumptions. Principle 5, use case scenarios combined with equivalence class partitioning define the most effective test cases. So use the use cases to identify the basic path, alternate paths, and exception paths, as well as combination of those paths, and then identify boundary conditions and create from the boundary conditions additional use cases. So essentially use the use case as the foundation for the development of a complete suite of tests. This works because use cases define the way the system is supposed to work, the way the user is expected to interact with the system, and the way the system is supposed to respond to the user. So it essentially defines the expected behavior. And that, of course, naturally is and should be the foundation of your test cases. Principle 6, track your test plans, test cases, and test results. Now, it might be obvious, but many testers often perform testing in a very ad hoc manner. And they essentially carry out tests without writing on the result, without understanding how they got to a particular result, without tracking particular test cases and being able to re-execute them later on. Instead, all test artifacts should be written and tracked in a repository, ideally a test database using a testing tool or testing platform. Similarly, defects should be tracked in a defect management system, so you can report on it, precisely the state of quality and the state of defects in a particular system. Above all, testing should not be an ad hoc or impromptu kind of activity. In fact, many forward-looking organizations have test engineers who are software developers who understand how to build these types of repositories and perform methodical testing. Of course, having tracked test plans, test cases, and test results means that you can eventually automate the tests as well. Without those, of course, automation would not be possible or feasible. Principle 7, focus testing on where defects are most likely. Now, defects are most likely at the edges of boundary conditions and where issues have arisen in the past. Therefore, focus testing on those areas is most critical and most fruitful if time is limited. Now, of course, it doesn't mean that you're not going to find defects or issues somewhere else, but if you have limited time, focus on those areas where it's most likely. Principle 8, be mindful of side effects. So when updates or changes are made to a solution, to some kind of a software system, to a software component, check that all previous functionality still works as expected. We call that regression testing. That means you want to perform regression testing by rerunning all tests if necessary. Only if you can prove that a particular change cannot have affected some particular part of the software system, you are bound to be required to re-execute all the test cases and all the test suites. So of course that means having them written down, having them be automated is most critical. Principle 9, verify the requirements before testing. Obviously, test cases and test plans should be based on and have to be based on defined and verified requirements. If you are building test cases around incorrect requirements or an incorrect understanding or interpretation of requirements, that of course means you're going to build the wrong test cases and you have the wrong testing results. So that means it is critical that all requirements be reviewed with the stakeholders and to obtain their approval prior to development and again prior to testing. Principle 10, create a safe test environment. That means do not run tests in the production environment. Should be obvious, but there are still many organizations who actually do most of their testing on the production, the operational environment. And of course, if anything goes wrong, they're affecting the production version of a system and potentially the operations of an organization. So rather than carrying out tests on the actual production environment, you should be carrying out tests in a safe test environment that mimics the actual production environment as closely as possible. Again, that often necessitates having test engineers set up these types of test environments. And finally, the most important principle, principle 11, assure quality throughout. Testing catches many, but not all mistakes in the implementation of a solution. But you can improve quality significantly, not by trying to test quality into your software system and into your software, but rather by conducting static testing in the form of requirements design and code reviews prior to implementation, using strategies like pair programming, unit testing, design by contract, proper object-oriented design to ensure that quality is simply part of the engineering of the solution rather than trying to find the defects later on and then patching them. So those are the 11 principles of successful testing and software quality assurance.